Talking about logical operators or logical operations with strings. I want to point out some things here. And all of it's based on these values, these characters being converted to their ASCII equivalents. And once you understand that and everything you understand about vectors, then this is very straightforward. So comparing A to A, does lowercase a equal lowercase a? That's like saying, is 97 equal to 97? And both of these are logically true. Comparing A to capital A is like comparing 97 to 65, and both of these are logically 0. If you do it with vectors, you come in here and you compare 1, 2, 3, oops, to the vector 4, 2, 5. It's going to do it element by element, so you're going to wind up with the vector. This is going to resolve to the vector 1 is not equal to 4, so that's going to give you a 0. 2 is equal to 2, that will give you a 1. And 3 is not equal to 5, so that's going to give you a 0, right? So if you did, let's say if you set this equal to some variable value e, then if you did all on e, then that's going to give you a false. If you did any on e, then that's going to give you a true, because at least one of those is true. Okay, so now let's look at how this plays out when we use strings. So MATLAB, let's say if we have H equals the logical expression PAN equals SAT. Okay, well that's just like saying, that's just like putting in the expression, converting these to ASCII codes. Does 112, 97, 110 equal 115, 97, 116? Okay, well, doing what we just did with the last vectors, that's going to resolve to a vector. Well, is 112 equal to 115? No. Is 97 equal to 97? Yes. Is 110 equal to 116? No. So you wind up with this. So if you did an all on H to see if these two strings were equal, you would come up with a false, because not all of them are ones. If you did an any on H, you would come up with a true. Okay. Same thing exists when you deal with greater than, equal to, or greater than, equal to, greater than, less than, or less than or equal to. Same reasoning takes place if I had n equal to PAN. Is that less than SAT? You're going to wind up with the vector. It's going to convert these to vectors just as it just did. 112, 97, 110. Is that, or are the values in that vector less than 115, 97, and 116? And so this is going to give you 112 is less than 115, so you'll get 1. 97 is not less than 97, so you'll get 0 there. And 110 is not less than 116, and so you'll get, 110 is less than 116, so you'll get a 1 there. So once again, if you did an any on this, if you did it all on this, it would give you a 0. If you did an any, it would give you a 1. Change it around a little bit. Let's say, we kept vector n, but you did a greater than instead. Now your resulting vector is 112 greater than 115? No. Is 97 greater than 97? No. Is 110 greater than 116? No. So you get this as a resulting vector. All right. So I'm going to use this, going to show this in next example. How do you compare two strings to see if they're equal to each other? But right now, I just wanted to point out that logically, When you use strings, they get converted to their ASCII equivalent in vectors, and then the logical operation is applied to each element, and you wind up with a vector that has a logical vector that has ones and zeros according to the comparisons of each element. So over here to MATLAB, running this code here, it's just what I had. Line 8, does lowercase a equal lowercase a? Yes. Does 97 equal 97? Yes, which is the ASCII values. Is lowercase a equal to uppercase A? No. And then that's just like saying, does 97 equal 65? And that's no. Here, E, you have the vector 1, 2, 3, the vector 4, 2, 5, and so it's going to compare each element to each element, so you wind up with E being 0, 1, 0. But you can see that's the case here. Then if you do an all on that, that's going to be a 0 because all of those aren't true, and the NE will be a 1 because at least one of those is true. Coming down to line 17, you're comparing pan and sat, and so you're going to get the vector 0, 1, 0 because P is not equal to S, A is equal to A, and N is not equal to T. So you get 0, 1, 0. That is the equivalent. It's going to what's happening in the background when you do line 17 is what's happening on line 18, is that pan is getting converted to this vector, sat is getting converted to this vector, and they're getting compared element by element. So you're going to wind up with the same response on line 18 as you had on line 17. So H and I are going to be equal. J, you're taking all of that, and so once again, if you're doing all on something that has at least 1 0 in it, it's not going to be true. K does it in a little different form. You just do an all on the pan equals sat, and then you're going to get the same result. That's not true. And then lines 21 and 22 do any's on the pan equals sat, both the ASCII number version of it and also the string version. So both of those you get a true because at least one of those is true. Coming down here to line 24 and 25, you're doing the same thing except one with strings, one with ASCII codes with the less than, and so we get what's expected out of N. P is less than S, A is not less than A, and N is less than T, and that's the same case on line 25 with the ASCII representative vectors. And then on line 27, you're doing the greater than, and you wind up with P not being greater than S, A not being greater than A, and N not being greater than T. And so you get the P's, the vector 0, 0, 0, indicating all of them are false, and Q on line 28 would be the same because it is the ASCII representation of that, and that's how MATLAB computes it.